Exercises. 1. Write detailed answers. A. Explain the difference between potential energy and kinetic energy. Answer. Kinetic energy, potential energy, I. Kinetic energy is the energy possessed by the body due to its motion. I. Potential energy is the energy possessed by the body because of its shape or position. 2 Ke equals half a meter versus squared. 2 Pe equals mgh. 2 e.g. flowing water such as when falling from a waterfall. 2 e.g. water at the top of a waterfall before the drop. B. Derive the formula for the kinetic energy of an object of mass m moving with velocity versus. Answer. Suppose a stationary object of mass m moves because of an applied force. Let u be its initial velocity, here u equals 0. Let the applied force be f. This generates an acceleration a in the object, and after time t, the velocity of the object becomes equal to v. The displacement during this time is s. The work done on the object is w equals f times s. 1. Using Newton's second law of motion, F equals ma. 2. Using Newton's second equation of motion. However, as initial velocity is 0, u equals 0. Therefore, s equals 0 plus frac 1, 2a t squared. Therefore, s equals frac 1 2a to the power of 2, 3. Therefore, w equals ma times frac 1 2a to the power of 2, using equations 2 and 3, I and 1. Therefore, w equals frac 1 2 meters times at to the power of 2, 4. Using Newton's first equation of motion, v equals u plus at. Therefore, v equals 0 plus at. Therefore, v equals at. Therefore, versus to the power of 2 equals a to the power of 2 to the power of 2 equals at to the power of 2, 5. Therefore, w equals frac 1 2 meters versus to the power of 2, using equations 4 and 5. The kinetic energy gained by an object is the amount of work done on the object. Therefore, Ke equals W. C. Prove that the kinetic energy of a freely falling object on reaching the ground is nothing but the transformation of its initial potential energy. Answer. Let us look at the kinetic and potential energies of an object of mass, m, falling freely from height, h, when the object is at different heights. As shown in the figure, the point A is at a height h from the ground. Let the point B be at a distance v, vertically below A. Let the point C be on the ground directly below A and B. Let us calculate the energies of the object at A, B and C. 1. Let the velocity of the object be v underscore b when it reaches point B, having fallen through a distance x. U equals 0, s equals x, a equals g, versus to the power of 2 equals u to the power of 2 plus 2as. V underscore BTO the power of 2 equals 0 plus 2 grams by. V underscore BTO the power of 2 equals 2 grams by. Therefore, Ke equals frac 1 2 meters versus to the power of 2 equals frac 1 2 meters, 2 grams by. Ke equals mgx, height of the object when at B equals hx. Therefore, Pe equals mg of hx, Pe equals mgh mgx. Therefore, total energy, Te equals K dot E, plus Pe equals mgx plus mgh, mgx. Therefore, Te equals mgh, I. 2. When the object is stationary at A, its initial velocity is u equals 0. Therefore, Ke equals 1/2 mass times velocity squared equals frac 1 2 meters a squared. Ke equals 0. Pe equals mgh. Therefore, total energy equals K dot E plus Pe equals 0 plus mgh. Total energy equals mgh. 3. Let the velocity of the object be v underscore c when it reaches the ground near point C. U equals 0, s equals h, a equals g, versus to the power of 2 equals u2, the power of 2 plus 2as. V underscore CTO the power of 2 equals 0 plus 2 grams h. Therefore, Ke equals frac 1 2 meters. V underscore CTO the power of 2 equals frac 1 2 meters, 2 grams h, Ke equals mgh. The height of the object from the ground at point C is h equals 0, therefore P dot E equals mgh equals 0, therefore Te equals K dot E plus P dot E. Te equals mgh. 2. From equations I and 2, we see that the total potential energy of the object at its initial position is the same as the kinetic energy at the ground. D. Determine the amount of work done when an object is displaced at an angle of 30 to the power of circ with respect to the direction of the applied force. Answer. When an object is displaced by displacement s and by applying force F at an angle 30 to the power of circ, work done can be given as W equals Fs cos theta, therefore W equals Fs cos 30 because theta equals 30 to the power of circ. Therefore, W equals Fs left, frac square root of 3 to right. Left, because cos 30 equals frac square root of 3 to right. E. If an object has zero momentum, does it have kinetic energy? Explain your answer. Answer. No, it does not have kinetic energy if it does not have momentum. Momentum is the product of mass and velocity. If it is 0, it implies that V equals 0, since mass can never be 0. Now, Ke equals frac 12 meters versus squared. So if V equals 0, then Ke also will be 0. Thus, if an object has no momentum, then it cannot possess kinetic energy. F. Why is the work done on an object moving with uniform circular motion 0? Answer. In uniform circular motion, the force acting on an object is along the radius of the circle. Its displacement is along the tangent to the circle. Thus, they are perpendicular to each other. Hence, theta equals 90 to the power of circ and cos 90 equals 0. Therefore, W equals Fs, cos theta equals 0. 2. Choose one or more correct alternatives. A. For work to be performed, energy must be I. Transferred from one place to another. 2. Concentrated. 2. Transformed from one type to another. IV. Destroyed. Answer. The correct alternatives are I and 2. Why these are correct? 2. Transformed from one type to another. Doing work almost always involves an energy conversion. A car engine performs work by transforming chemical energy, fuel, into mechanical energy, motion. I. Transferred from one place to another. Work is essentially the process of moving energy from one system to another. For example, when you kick a ball, energy is transferred from your leg to the ball. B. Joule is the unit of I force, 2 work, 2 power, IV energy. Answer. The correct alternatives are 2 and IV. Why these are correct? 2. Work. By definition 1 joule, 1 J, is the amount of work done when a force of 1 Newton moves an object a distance of 1 meter. IV energy. Since energy is the capacity to do work, it is also measured in joules. Whether it is thermal, kinetic, or potential energy, the joule is the standard SI unit. C. Which of the forces involved in dragging a heavy object on a smooth horizontal surface have the same magnitude? I. The horizontal applied force. 2. Gravitational force. 2. Reaction force in vertical direction. IV force of friction. Answer. The correct alternatives are 2 and 2. Why these are correct? 2. Gravitational force. This is the weight of the object acting downward. W equals mg. 2. Reaction force. Normal force. This is the force the surface exerts upward to support the object. D. Power is a measure of the I. The rapidity with which work is done. 2. Amount of energy required to perform the work. 2. The slowness with which work is performed. IV. Length of time. Answer. The correct alternatives are I and 2. Why these are correct? 2. The slowness with which work is performed. Because power is an inverse measure of time, it effectively measures the speed or lack thereof of the work being done. A low power output means the work is being performed slowly. I. The rapidity with which work is done. This is the standard definition of power. If you do the same amount of work in less time, more rapidly, you are using more power. E. While dragging or lifting an object, negative work is done by I. the applied force, 2. Gravitational force, 2. Frictional force, IV reaction force. Answer. The correct alternatives are 2 and 2. Why these are correct? 2. Frictional force. When you drag an object across a surface, friction always acts in the opposite direction of the motion. Since it opposes the movement, friction always does negative work. 2. Gravitational force. When you lift an object upward, gravity is pulling downward. Because the movement up and the force down are in opposite directions, gravity does negative work. 3. Rewrite the following sentences using proper alternative. A. The potential energy of your body is least when you are I. Sitting on a chair, 2. Sitting on the ground, 2. Sleeping on the ground, IV. Standing on the ground. Answer. The correct answer is 2. Sleeping on the ground. B. The total energy of an object falling freely towards the ground. I. Decreases, 2. Remains unchanged, 2. Increases, IV. Increases in the beginning and then decreases. Answer. The correct answer is he 2. Remains unchanged. C. If we increase the velocity of a car moving on a flat surface to 4 times its original speed, its potential energy I will be twice its original energy, 2 will not change, 2 will be 4 times its original energy, IV will be 16 times its original energy. Answer. The correct answer is he 2 will not change. D. The work done on an object does not depend on I. Displacement, 2. Applied force, 2. Initial velocity of the object, IV. The angle between force and displacement. Answer. The correct answer is 2. Initial velocity of the object. 4. Study the following activity and answer the questions. 1. Now take 2 balls of the same size and weight and release them from the top end of the channels. They will roll down and cover the same distance. 2. Take 2 aluminium channels of different lengths. 3. Place the lower ends of the channels on the floor and hold their upper ends at the same height. Questions. 1. At the moment of releasing the balls, which energy do the balls have? 2. As the balls roll down, which energy is converted into which other form of energy? 3. Why do the balls cover the same distance on rolling down? 4. What is the form of the eventual total energy of the balls? 5. Which law related to energy does the above activity demonstrate? Explain. Answer. 1. At the moment of releasing the ball, they possess potential energy as they are at a height above the ground. 2. As the balls roll down, the potential energy is converted into kinetic energy since they are now in motion. 3. Since they have been released from the same height, they will cover the same distance. 4. The eventual form of the total energy of the balls is mechanical energy, i.e., a combination of potential energy and kinetic energy. 5. The above activity demonstrates the law of conservation of energy. 5. Solve the following examples. A. An electric pump has 2 kilowatts power. How much water will the pump lift every minute to a height of 10 meters? Ans. 1224.5 kilograms. Answer. Given power of P equals 2 kW equals 2000 W. Height H mine equals 10 meters. Time Ft mine equals 1 minute equals 60 s. Acceleration due to gravity dng mine equals 9.8 meters per second squared. To find mass of water, m equals formula P equals frac mght. Solution m equals frac ptgh. m equals 1224.5 kg. B. If a 1200 W electric iron is used daily for 30 minutes, how much total electricity is consumed in the month of April? Ans. 18 unit. Answer. P equals frac 1200 1000 equals 1.2 text kW. T equals frac 3050 equals 0.5 text h. Text E equals text power times text days equals 1.2 times 0.5 times 30 equals 18 text kWh. C. If the energy of a ball falling from a height of 10 meters is reduced by 40%, how high will it rebound? Ans. 6 meters. Answer. Given, initial height, h_1 equals 10 meters. Let initial, PE_1 equals 100. Final, PEE_2 equals 100 minus 40 equals 60. To find final height, h_2 equals, formula, PE equals mgh. Dividing 2 by I. h_2 equals 6 meters. D. The velocity of a car increases from 54 km per hour to 72 km per hour. How much is the work done if the mass of the car is 1500 kg? Hence, 131,250 J. Answer. Given, mass m equals 1500 kg. Initial velocity, when u equals 54 km per hour r, equals 15 meters per second. Final velocity equals 72 km per hour r, equals 20 meters per second. To find work done to increase the velocity equals, formula. Solution. Equals 750 times 175 equals 131,250 J. E. Ravi applied a force of 10 N and moved a book 30 centimeters in the direction of the force. How much was the work done by Ravi? Ans. 3 J. Answer. Force F equals 10 N. Theta equals 0 to the power of circ, since force and displacement are in same direction. Displacement S equals 30 cm equals 31/100ths of a meter. To find work W equals, formula. W equals Fs cos theta. Solution. W equals Fs cos theta. The work done by Ravi is 3J. Equals 3J.